Hello students, today we are going to discuss our new type of integral that is written as integration of some special irrational algebraic functions. Okay, our new type of integral is written as integral of phi of x dividing by p into under root of q dx. Okay, so what is p and what is q? Students, p is a linear expression. P is a linear expression or quadratic expression. P could be linear expression or a quadratic expression. Q is a linear expression or a quadratic expression depending on the situation, depending on the condition from which we have given an integral. Okay, clear? So students, there are four cases arises in case first when both p and q are linear expression. In first case, when p and q both are linear expression of x. In case 2, when p is a linear expression of x but q is a quadratic expression. In case first, both p and q are a linear expression of x. In case 2, p is a linear expression of x but q is a quadratic expression of x. In case 3, p is quadratic expression, and q is a linear expression of x. In case 4, both p and q are quadratic expression of x. Clear? Okay, in case first, both p and q are linear expression of x. In case 2, if p is a linear expression and q is quadratic expression. In case 3, if p is a quadratic expression and p is a linear expression. In case 4, both p and q are quadratic expression of x. Okay, so these are four cases depending on the nature or characteristic of the two expressions p and q. Both are present in denominator of the given fraction. Okay, clear? So how we can find the integral when our denominator is completed by multiplication of two functions, and that function is using case first. Using case first, when our denominator contains two linear expression, in which p is linear expression and q is also a linear expression. For example, suppose we have given 1 upon ax plus b and second one is under root of cx plus d dx. Okay, clear? In this example, we have given integral of 1 upon ax plus b is a linear expression of x into under root of cx plus d, which is another linear expression of x. Okay, so for integration of such type of integral, we have to put cx plus d is equal to t square. Cx plus d is equal to t square. Clear? Means we have to put t square at the place of which is our in radicand sign, that is under root of cx plus d. We have to use cx plus d is equal to t square. So our substitution is cx plus d is equal to t square. When both expressions are linear expression of x. Clear? Okay. This one is example depending on case first, that is case first. In case 2, if we take an example that is written as 1 upon p is a linear expression. P is a linear expression. Suppose that is ax plus b under root of q is our quadratic expression, that is ax square plus bx plus c dx. Okay, then what is the substitution? What we have to substitute to find integral of such type of integration? Okay, so in this way, in this condition, we have to take ax plus b is equal to 1 upon t. Okay, we have to put ax plus b is equal to 1 upon t, and after taking means what we are doing? We are doing that we are changing whole system which is in function of x in t. We are changing x functions which are in x in the form of t. For this we have to change dx in the form of dt. For that we have to take derivative of both sides and we get dx in the form of dt. Okay, here also we are changing the functions which are in x in t. Okay, so we have to change dx in the form of dt. For that we have to take derivative of both sides in the form of dt. Okay, clear? In case 3, when p is a quadratic expression, when p is a quadratic expression, that is 1 upon ax square plus bx plus c under root of, and q is a linear expression. Let this one is px plus q. Px plus q is a linear expression of x. Here p is a quadratic expression and p is a quadratic expression and q is a linear expression of x. So what is the substitution? What we have to substitute to find integral of such type of integration? Okay, then we have to put px plus q is equal to t square. Okay, px plus q is equal to t square means the function, that is linear expression which is present in radicand sign in under root. Okay, we have to put t square at the place of linear expression which is present in radicand. Okay, which is in under root. So px plus q is equal to t square means we are changing the functions which are in x in the form of t. So for that we have to change dx in the form of dt after taking derivative of both sides, etc. Clear? And in case 4, when both p and q are quadratic expressions, when both expressions that are p and q are quadratic expression. So for that, let the example for this 1 upon ax square plus bx plus c, which is p. Okay, that is first expression in x, and second one is under root of, let px square plus qx plus c. This one is our second quadratic expression of x. Okay, so in case first or after on following case 4, when both p and q are quadratic expression, we have to substitute x is equal to 1 upon t. Okay, what is the substitution for this type of integral? When both p and q are quadratic expression, we have to put x is equal to 1 by t. Okay, and after taking derivative, that is dx is equal to minus 1 upon t square dt, we can change all functions which are in x in the form of t and dx also converted into dt. Okay, I am repeating. Our new type of integral is given as integration of phi x upon p into under root of q dx, where p and q are two linear or quadratic expressions depending on the situations. Okay, so there are 4 cases when both p and q expressions are linear expressions of x. In case 2, when p is linear expression but q is a quadratic expression of x. In case 3, when p is quadratic expression of x and q is a linear expression of x. And case 4, when both expressions are quadratic expression of x. Okay, for first case we have to put cx plus d, which is a q, which is q is equal to t square, and after means we have to change the functions which are in x in the form of t. So for that we have to convert dx in the form of dt. Okay, in case 2, when p is a linear expression of x and q is quadratic expression of x, so we have to put linear expression is equal to 1 by t, and after taking derivative of both the sides we get dx in the form of dt, and all the functions which are in x converted into t. Okay, in case 3, when p is quadratic and q is a linear, so for this process we have to assume the linear expression which are present in under root. Okay, in radicand sign is equal to t square. After taking ds in the form of dt, we can find the integral. In case 4, when both the expressions are in quadratic form, in quadratic expression of x, we have to put x is equal to 1 upon t. Okay, so this one is our some special irrational algebraic functions and their substitutions.